Example 5, we have a beam that is restrained by two pin support at two ends. It's made of a standard steel shape, and the information has been given here. No stress in the beam at room temperature. The beam is taken to an oven for a test where it's heated up by a delta T equals 140 degrees Celsius. Ignore the self-weight and determine the maximum normal stress in the beam in two different cases. In case 1, the pin supports are at the centroid of the section. Case 2, the pin supports are at the centroid of the flange. Okay, the cross section is shown here. The overall centroid is somewhere here, right? And the centroid of the flange will be here. Okay, so let's look at the case 1 first. Okay, case 1, if the pin supports are at the centroid of the section, it will become the problem that we have talked for a couple of times when we talk about the thermal properties, and when we talk about the indeterminate axially loaded element. The last example, okay, we showed how to solve the thermal stress problem using the principles of indeterminate axially loaded elements. Okay, so there in case 1, I will just briefly review this method. In case 1, supports at the centroid. Okay, so if the support is at the centroid, this T shape is not different from a circular bar or a other shape of uniform material, uniform components, right? So here the compatibility condition tells the thermal deformation plus elastic deformation equals 0, right? So that is the alpha delta T times L plus FL over EA equals 0. Okay, the LL is gone, right? So we can solve this F. That is negative alpha delta T times EA. Okay, using the numbers given in this example, we can calculate that is negative 843,500 Newton. Okay, this is a compressive stress. You can review, you can just recall the principles of thermal stress. Okay, so when it's heated, both ends is fixed. When it's heated, it tends to become longer, but it's not allowed. So equivalently, we're pushing it back to the original position. Okay, so it is in compression. Okay, negative force. Okay, if we know the force, then the stress will be easy. F over A. Right, negative 843,500 over the A here. Right, 5890. So we get negative 143.2 MPa. So that is all for case 1. But for case 2, right, it will be, of course, it will be combined loading, right, because this will become an eccentric loading, right, because the F is added here, right, not the overall centroid. So the E will be here, so we can calculate this E, right? So this E will be y bar minus half of the thickness of the flange, right? The y bar is here, so this E equals y bar minus half of the thickness of the flange, that is TF over 2. Okay, so to solve the second case, the first step, of course, we will need to figure out F and M. Right, F, we have determined that is negative 843,500 Newton, and M is 843,500 times the E, right? This is Y bar minus TF over 2. And this will be Y bar at 65.5 here minus half TF, 15.6 over 2. We got 57.7 millimeter. Okay, so the M will be 48.67 million Newton millimeter. Okay, second step, A, 5890 here, millimeter square, and I, here, right, this is 39 million millimeter to the fourth. Okay, then the third step, we can calculate the components, their components, right? This is the sigma 1 would be F over A. That is the same as here, right? It's a negative 143.2 MPa. Right, the second component would be MC over I. Of course, it will have different C values, right? Different C values. So on top, it will be negative, right? You will be compressing it in this way, right? So the bending moment will be in such a manner, right? So on top of it, it will be negative. On bottom of it will be positive. Okay, so on top it will be negative. Then it will be negative M times Y bar, right? The C is just Y bar over I. The result will be negative 81.7 MPa. And on the bottom, it will be positive, right? It's a positive M times D minus Y bar. Right, the overall depth D minus Y bar over I. So it will be 251.5 MPa. Okay, then the final step, the stress on top will be negative 143.2 minus 81.7. It will be negative 224.9 MPa. And at the bottom, it will be negative 143.2 plus 251.5. It will be 108.3 MPa.